Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the development of the lateral surfaces of the solids using the Solid Edge software. Here we have a frustum of a square pyramid with its base equal to 40 mm and top side being 16 mm and also the height of the frustum equal to 60 mm. Its axis is vertical and the side of its base is parallel to VP. We need to draw the projections of the frustum and show the development of the lateral surfaces of it. So here we can understand that the frustum is nothing but the remaining portion of the prism after a plane has cut it parallel to the ground, and that is what is the frustum. So with respect to the frustum, the data given here is the base of the square pyramid, that is the bigger square is measuring 40 mm sides, and then the top of the frustum, which has got a smaller circle, is measuring 16 mm in each of its edge, and also the height of this frustum is 60 mm. And please do not confuse this height to the height of the pyramid. So this is just the height of the frustum. And also the resting condition is one of its edges is parallel to the VP. So this is possible only when the square pyramid is resting on one of its edges. Only then one of its side can be parallel to VP. So we need to draw the projections of the frustum and show the development of the lateral surfaces of it. So we can proceed by constructing the XY line of thickness 0.18 mm. So since the height is not known, it is always advisable to draw the XY line at a bit lower position so that we have got sufficient height to complete the height of the pyramid, which is not given to us in the problem statement. So now let us complete the first top view of the square pyramid. So each side here measures 40 mm. So enter 40 for all the four edges and the square is ready. So select the square and then move this to a comfortable position and also ensure that it is resting on one of its edges like this. Only then, as you can see here, the edges is parallel to the vertical plane. So this is the first position. So now what we will do is we will mark the triangular faces of the pyramid by drawing the diagonals of the square. So this completes the top view of the square pyramid. So from each of the corners, let us take the projections, intersect the XY line, and then draw the top view. So, but however, we do not know the length of the axis here. So what I'll do is, from this axis point, I'll just draw a line of 60 mm. So select 0.13 mm and select the axis line. So let me draw a line of length 60 mm, which is the height of the frustum given to us. So the frustum is nothing but the base is a bigger square pyramid whose top view is shown here. And here the top view will also be a square and that square will measure 16 mm. So what I'll do is I'll select the line option, ensure it is a continuous line, and then on either sides I'll take up a line measuring 8 mm so that the 16 mm line is bisected by the axis like this. And then from the end point of this, I'll just join the base of the square pyramid. So this is the frustum of the square pyramid. The front view is as shown here. So now I need to construct the top view of this. So what we can do is we can just drop a perpendicular and then cut the edges, that is the diagonals, complete the top view, and then draw the projection line. So this completes the construction of the frustum of the square pyramid. So go for the smart dimension. So this is 40 mm, and here this is measuring 16 mm. So this is measuring 16 mm. So you can just see here the top view also it is measuring 60 mm, and then in the top view again this is measuring 40 mm. So the height of the frustum is equal to 60 mm as given in the problem statement. So now this completes the first construction, that is the frustum of the pyramid in the front and the top views. But to construct the development, I require the entire pyramid. So what I can do is I'll simply extend this axis line to an arbitrary length. So I'll select this axis line and I'll simply extend this axis line to a arbitrary length. Now I'll use the extend to next option and place the cursor on the slant edges. So this slant edge, so you can just see that the two slant edges are meeting at this point. So now I'll use the trim option and trim this remaining part of the axis line. So this is the actual height of the pyramid. So this is the axis of the pyramid, and then this is the axis of the frustum, which was equal to 60 mm. And this completes the entire front view of the square pyramid. And also, we can see that we cannot consider this edge as the true slant edge because none of the triangular edges are parallel to the reference line. So what I'll be doing is I'll construct a true slant edge. So what we can do is select a line of thickness 0.13, draw a line parallel to the xy line, go for arc by center point, measure the arc of radii which is equal to this slant edge. So cut an arc. So from the end point of this arc, intersect the xy line. From this point, extend this to the tip of the pyramid, that is the apex point, like this. So this dimension will be equal to the length of the true slant edge of the square pyramid. So with this, we have completed the actual position of the square pyramid. So now let us do the annotation. So let us first begin by annotating the reference line as x and y. So this is x and this is y, and also the planes are VP and HP, where the front and the top views are recorded respectively. So we'll start with this corner. So this is corner A, this is corner B, this is corner C, and this is corner D. Also, O is the apex of the pyramid, and inside the bracket O1 will be the center of the base of the pyramid. So now we'll go for annotating the front view. So this is the apex of the pyramid, that is O dash. So this is the apex of the pyramid, that is O dash, and this is the base center point, this is O1 dash. And similarly, this corner here will be C dash, inside the bracket D dash. And here this will be B dash, inside the bracket A dash. So with this, we complete the annotation of the front view of the pyramid also. So this true slant edge, what I'll do is I'll just annotate this as the point C1. So OC1 is the true slant edge, and here it will be C1 dash. So O dash C1 dash will be considered for constructing the sector of the circle. So we have to sweep a radii which is equal to 103.92. So now we can just go for transferring all these points. Okay, so the cutting plane here has already cut the pyramid, and the frustum of the pyramid is available to us. So go for the line option, select the line of thickness 0.50, and simply highlight this portion of the pyramid which is the frustum of the pyramid. So you have to take this slant edge, not the true slant edge. So go for the trim option and just trim this. So this will be a reference line of 0.13, so not a thick line. So this is the frustum of the pyramid. Similarly, complete the top view. So go for line option, select a line of thickness 0.50 mm, and then all the points will be on the corners. So this is the base of the pyramid, and this is the top face of the pyramid, and then connect the slant edges. So as you can see that the frustum is developed when a cutting plane is going to cut the pyramid such a way that the cutting plane is parallel to the ground or parallel to the base of the pyramid. Okay, so this is the frustum of the pyramid, as you can see. So for our reference, we can still nomenclate this point as, so we'll call this as A1, B1, C1, and then D1. So the same points can be nomenclated even in the front view also. So I'll go to this annotation. So this will be b1 dash, and inside the bracket a1 dash, and here this will be c1 dash inside the bracket d1 dash. So this completes the front and the top views of the frustum of the square pyramid. So now we need to complete the development. So first step is select the line option of thickness 0.13. Go for arc by center point. So on any arbitrary point, just sweep an arc which is having the radii equal to 103.92. So cut an arc and then connect one end of the arc with a straight line to the center point, and from that point you can take the reference and start cutting the arc which is having a radii which is equal to 40 mm. So just sweep 4 arcs so that you are dividing the arc into 4 equal parts. So since the square will be having 4 triangular faces, we'll be dividing this into 4 equal parts. 40 mm. So this completes the division. So now join the point of intersection to the apex of the pyramid. So this is nothing but the initial cut section of the pyramid. So you have to be very careful. You have to join it only to the point of intersection. And then join the edges. Use the trim option. Trim the remaining portion of the arc and then trim this construction arc also. So now we have completed the sector, which is nothing but having a radius equal to the true slant edge, that is 103.92. So now we will annotate. So this is the apex O of the pyramid, followed by the corners of the base A, B, C, D, and again A. So now we will not label anything as 1, 2, 3 here. Instead, we'll just identify the points of A1, B1, C1, D1, okay, on this respective slant edges. So we can just use the line option here. So extend this point to the true slant edge. So you can just see that all the 4 points will be lying on the same line. So that is on this true slant edge. So go for the distance between. So this is the distance 41.57. So since the point is common for all the 4 slant edges, what I can do is I'll go for the arc by center point. I'll select this as the center of the arc again and sweep a radii of 41.57 such that it is intersecting all the 4 slant edges. So now I'll be using the line option and then join them to the point of intersection as the straight lines. So it cannot be a curved line because it is a flat cutting plane, correct? So this completes the development. So use the trim option now. So trim this curve beneath the straight line and then join this using the line of thickness 0.50 mm. So this is A1 to A, B to B1, then this is C1 to C, and then B again, C to the point D, D to the point D1, C1, D1 to A1, A1 to A, and A to D. So go for the annotation. So this is A1, this is B1, this is C1, this is D1, and this is okay. So you can just see that it is not exactly on the initial portion of the pyramid. So such errors will happen. So you have to take care of the zoom options. So go for the line option again. So just retrace this path. So choose the endpoints properly, and also this portion. Okay. So this point is A1. So with this, we complete the development of the frustum of the pyramid. So you can just annotate this portion as the development, indicating that this is the required development of the frustum of the square pyramid. So to sum up, we have got a square pyramid. So the pyramid axis length was not given to us, but the frustum axis length was given, and the data regarding the base edges of the top and the bottom face was given. So using this, we constructed the frustum first, and then completed the pyramid. And then we have considered the cutting plane. So since the frustum is the remaining portion of the prism when it is cut by a plane parallel to the ground, so we assume that it is a straight surface, and then we complete the development using this procedure. So with this, we complete the construction for the given problem statement. So just show the edge length of any one of these edges on the sector. So this is the true slant edge, which is generated by rotating one of the slant edge parallel to the XY line. So we have completed the construction. Thank you all for watching.